Should be good. Thank you.
All right, thank you. Hi, everyone. My name is Sam Nasr, and this session is on adding machine learning to .NET applications. A little bit about me. You can find me on Twitter at Sam Nasr. I've been a software developer since 1995, and I'm currently the senior software engineer for NIS Technologies. Also, I've been certified with a few certifications from Microsoft, and I run the Cleveland C# VB.NET user group. And if you're interested, we're actually going to be meeting tonight at 6 p.m. Eastern, so approximately an hour 45 from now. And the meetings are free of charge and open to the public. And we have Jeff Fritz from Microsoft discussing .NET 7. And I can share the link with the group shortly afterwards. In addition, I also run the .NET study group, which meets online. And I've authored approximately 17 articles for Visual Studio Magazine. And I've been a 5-time Microsoft MVP. In addition, one of the user groups that I also am involved in the Cleveland area is the Azure Cleveland user group. So chances are, if you're interested in machine learning, you're going to have interest in an Azure user group. We meet every second Wednesday. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure. So you can find meeting information over on meetup.com at the link listed below. So with that, let's jump into our presentation, which is going to be using machine learning for .NET applications. So in order to do that, basically you're going to be using a model for providing machine learning and you can incorporate this in .NET or .NET Core applications. That model could be available in an online or offline scenario. And it uses patterns of data to be able to make predictions, as opposed to explicit logic, meaning we're not giving it a specific formula, but rather we're giving the model a variety of data. Hopefully it's clean data, and the model will then be able to decipher, depending on the features that are presented in that data, it will be able to predict the end results. And essentially what the ML.NET model is, it's basically an object that contains the transformations or the logic for being able to predict a specific value based on a specific set of items or features. And so some of the things that we can come up with is basically simple linear regression, where we can see, for example, the price of a home. It's directly correlated to the square footage. Obviously, there's a lot of other factors that go into that, but for the most part, the larger the home, the bigger the price. Vice versa, you can also have linear regression in a inversely proportional, where, for example, you have BMI and the good cholesterol. So as your BMI rises, your good cholesterol drops. And so that's also a pattern that the machine learning model could pick up on. So before we get into an actual demo, we need to cover the basics of the terminology. And first and foremost, a feature is what's considered an input for the machine learning model. So a feature could be considered as the square footage of a home or the size, the mileage of a vehicle where we're trying to predict the price of it. And then on the other side of that token are the label, which is the value that is going to be predicted, or the output price. And these are ground truth values that are used to train a machine learning model. And what that means is I'm going to give it a list of homes that have the square footage. 1,000 square feet is going to be, let's say for the sake of easy math, it's going to be $100,000. A 2,000 square foot will be 200,000. And so when we give it that data, it will eventually be able to derive a correlation of the square footage to the price, and the feature would then be considered the square footage. The price would be the label, or the output value. And then what happens in between is what's called the transform. That's essentially the logic that's used to be able to derive the type of prediction. Now, as far as predictions, there's a variety of different types that are available. You have classification and categorization, where we're going to be classifying it into one or more categories. You have regression, similar to what we talked about earlier, where it's basically a scale, such as square footage with a home, or mileage and the price of a vehicle. We can also use it for anomaly detection and making recommendations. And there's also image classification, and we'll see all the various models that are available to us once we start getting into the demo. when we develop the model, basically it's a cyclical process in the sense that, as you see at the very top of the graphic, first and foremost, we're going to collect and load the data. And then we're going to create a pipeline. And you see that there's a method here called append. And then we're going to train that model. So by training the model, essentially it's going to go through that data. And we're going to call the fit method, which will run the algorithms on it. And then after we're done, after we have trained that model, then what we want to do is evaluate it to check to see its accuracy. And if it's not accurate, then the cycle repeats again, where we feed it more data, train it, test it, and so on. When we get to the point where you see at the bottom of the train model box, when we get to the point that we're satisfied with it, we tested it, and everything is kosher, then what we want to do is be able to save that model, and we do that using the save method. And the purpose of saving that model is so now we can take it, pass it on to other team members, or use it in another project and be able to use it to be able to predict a value. In order to be able to use the model, what we're going to do is essentially utilize the load model or the load method, and then we're going to use a create prediction engine method. And this is going to allow us to be able to, create prediction engine dot predict. So the dot predict is what actually we're going to pass it in a value, and then it's going to be able to predict the outcome or the output correlating to that. Now, in order to be able to do that, there's a couple prerequisites that are tied in. So first and foremost, I need to be able to have the .NET Desktop development environment loaded. And more specifically, if you notice over on the right-hand side, I need to select the ML.NET Model Builder. Once you have all those items selected, then what it'll allow you to do is once you have a project created, then you can just simply right-click on it, select Add, and there you see the machine learning as one of the items that can be added on. And this can be added on in the same manner that we add a class onto an existing project. So this can be done through the UI, as we see here in Visual Studio. It can be done programmatically using Microsoft.ml NuGet package, or it could be done through the command line interface. And so like everything else, it is better explained through a demo. And so let's step through that. And let me open up Visual Studio. So this is the opening screen for Visual Studio 2022. And what I have it is I got it at a point where I've selected a console application in C#. I named it ML Demo Nasr. And then I specified the path.
Hey, Sam, we still see your slide deck, I think.
Really? Okay, sorry about that. Let's see what we can do here. How's that?
There we go. Yep.
All right. Sorry about that. Okay, so once again, I have Visual Studio 2022 open, console application in C#, and I called it ML Demo Nasr. I specified the path where I want it to be located, and now I will go ahead and click Next. I'm going to be utilizing .NET 6.0 long-term support. I'm going to click Create. And then you'll see that it's chugging and creating the basic template for the solution. And you click and drag this over. And there's my Visual Studio solution. Very bare bones, console application, very basic. If we look at program.cs, again, there isn't a whole lot to it, just a simple hello world message. So what I'm going to do at this point, right-click on my project, and I'm going to select Add, and there I see Machine Learning Model. And again, the prerequisite for that is I installed my desktop environment, and I was sure to select ML.NET to be included in it. And so I will go ahead and select that. And I'll leave the default name mlmodel1.mbconfig. Select Add. Now I'm presented with a variety of different scenarios for building my model. Do I want to use data classification, value prediction, image classification, so on and so forth? And if you notice, all the various models underneath, they're listed with local, where they can be trained, or some of them I could actually utilize Azure for training them. For this demo, I'm going to use the data classification, which is going to be run locally. So once I select that, it takes me to the next step where it's specifying my environment. I'm going to be training it on my local CPU. And this is a giveaway of the processor that I'm running. And then I'm going to select next. And here I have the option to utilize the data. Am I going to be reading it from a file or from a database? So in this case, I have a file local on my system, and I downloaded some demoed data from Yelp. And just to give you an idea of what that looks like, let me go ahead and open that up in the world's greatest file editor, also known as Notepad. So what this is, it's basically a tab delimited file. And I have the comments here, such as, wow, I love this place. Crust is not good. And in case you haven't wondered, these are comments relating to a pizza restaurant. And so the comments are listed as either 1 for positive or 0 for negative. So I have all my comments going down here in the first column, and then what those type of comments are, whether they're positive or negative, listed in the second column. So let me go ahead and close that. And I'm going to select that file and import that into my model. Now, if you recall, when we talked about training the model, we have to provide a data. And then after we provide the data, we have to identify what's a feature and what's a label. And so a feature is something that it's going to be trained on. So we're going to select column 0, which is the actual text here, and it shows you a preview 10 of the first 1,000 rows of the file that I selected. So I'm selecting the first column, which is what I wanted to train on, and then this is the outcome in column 1 here. I'm going to select the next step. And here it says start training. It's giving me for 10 seconds as the default. I'm going to go ahead and click that, and as you see, it's going to start training it. And I'll show you something very interesting as soon as it's done. Whoops, pardon me. Oh, sorry, I made a slight mistake. Let me back up. All right, let's go back to data. So I want to select column 1, which is the output. That's the label. And then I want to select next, and I'm going to train it for 20 seconds this time. I'm going to select train again. And it's going to go through, and basically, if you look down at the output window, you'll see that it's chugging through a variety of different algorithms, looking at the data, looking at the features and the output value, and then it's giving me a best accuracy value here. And now it's finalizing the model. And now it's giving me the ability to move on to the next step. The next step, now after I've trained it, I need to test it. So I can select predict. So I'm using a comment here. This is the first column listed in the file. And when I select predict, it comes back as 50% positive, 50% negative. It's not sure. And I think the reason for that is because I had messed it up when I created the model. So let me backtrack even further. Let me delete the model altogether. And I'm going to add in the model again. Again, select add, machine learning model. data classification, and we'll select the file. And this time we want to go for column 1. Next, train it for 10 seconds. And again, as you see through the output window at the bottom, it's going through a variety of different trainers. And got an error. Well, expect it when you least expect it, right? Let's try that again. All right, another 3 seconds to go. And there you see the output. Now, right now, the best accuracy that it came up with for those 10 seconds on those 1,000 rows that I provided it was 49.91%. If I was to increase that to 20 seconds, and let's go ahead and train it again. And pardon me while I take a quick drink. And after it's done, you should see that this best accuracy percentage should increase significantly after the model is being finalized. And we'll give it just a second to finalize. Okay. Well, let's see what happened now. All right, so we're going to do next step, and we're going to test it. Okay. And I think what happened here is I ran into a problem with Visual Studio, and I'm still getting this error message. But essentially, what I could do is I could restart it, but let's assume that I'm happy with the results here. The next step at this point would be to be able to utilize that model that I built, which is this mlmodel1.mbconfig. I want to be able to use that in a project, in another project. So here it's giving me the option. I can use it in a code by using another project template. I can add it as another console application. I can add it as a web API to my solution. And there you see links to add it to my current solution. Or I can just simply utilize the code here as a code snippet to include that in my application. So what I'm going to do is I'm going to add it to the solution. And there's the default name, console app 1. Go ahead and click add to solution. And now you'll see that it created a completely different project over in my Solution Explorer. And they're all basically named ML Model 1. I have the .consumption.cs, and as stated on top, this file is auto-generated by the MLNet model builder. And then we have the config, which is basically the same UI that I ran through earlier, but if I need to modify it, I can do that again. And then the training.cs, where here, there's a lot of instantiation for the model and getting it into the pipeline to be able to utilize it. And what it's doing here is that it's setting the various column values, setting the features, setting the output values, labels versus features. It's identifying which column's a label, which column's a feature, to be able to build a pipeline and train it. And then this model 1.zip, this is the actual model that was built previously in the other console application, the initial one that I started with. And so essentially, once I built this ML model 1.mb config in the first project, it converted into a .zip, copied it over into the second console application. And now there is code in here in both consumption.cs as well as training.cs to be able to instantiate that model and be able to use it. And if we look at the program CS of my new console application, again, you'll see the comment that this was auto-generated. And if we look at the main method of that, basically what we're doing here is we're instantiating the model using sample data. Excuse me, let me rephrase that. We're instantiating the model input, and then we're giving it a value of, wow, love this place. So by default, this is the first column that it's using. And then after that, it's going to run through the prediction model. And I'm passing it in the sample data, which is what's defined here. After that, I'm going to display the results in the prediction result.prediction. So when I run my application, let me make the second console app my startup project. And there's my console window. And so it's coming up with it's displaying the comment, it's displaying what it should be. And again, I think because I messed up the model, that's why it's coming up with the column 1, 0. And so I think if I can show you another demo that I had worked with previously, let me close this one. And let me fire up another demo created previously, again, along the same lines. So this demo, using the same file, the same features, the same labels, everything is identical. I think the mistake that I made in creating that live demo is I selected the wrong column by accident, and that's why I threw everything off after that. So there you see some very familiar names. We have the ML1, ML model 1.mb config, and then I copied that over into my, created another console application. And because this one is trained correctly, let me go ahead and run that. And there's the console window. It should come up with the same text that we've seen before, where it's going to be passing in a sample sentence or sentiment rather, and then should be coming back with the output results. So there we see I put in the comment "Great Pizza Place." The column or the output should be a 1, and here the predicted column 1 or the output is also 1. So the result. So this one was trained correctly, and hence you see the correct result produced here. I can further modify things and go back into my program.cs and in a negative comment. And now let's see how well it predicts that. And it's spinning up. All right, that didn't work as expected. Well, it's been a great day for demos today. All right. Okay, now the reason that had happened is because I need to train it longer on more data. And we'll talk about that in just a little bit. But I wanted to pause here and see if there's any questions I can answer. Alec, do you see any questions in chat?
I do not.
All right. If there's any questions, please feel free to jump in at any point in time. Otherwise, we'll continue on. All right, so another demo I'd like to show you is with the prediction of house values. And if you'll give me just a moment to open that up. So this model was built in Visual Studio 2019, and essentially similar concept as far as being able to do things, build a model, but this one we're doing it programmatically as opposed to stepping through the UI. So let me step you through it as it's loading up right now. And if you recall, there's three different ways to build a model. We can do it through the UI with the selection that we went through earlier. We can do it programmatically. And last but not least, we can do it through the command line interface. So this is a solution called house prices. And what I did was, because I didn't go through the UI, I did it programmatically. So I incorporated my Microsoft.ml NuGet package, first of all. And then I am creating my data, the house data, kept it very simple. It's composed of the size of the home in square footage and the price of the home. The prediction is going to be the score. I'm going to label that as the score, and that is going to be the final price of the home. And then when I enter into main, this is where rubber meets the road. Again, it's another console application. What I'm doing here is I'm instantiating the ML context, and then the first step is I'm creating the data. Obviously, this is hard-coded data, and I'm only providing 4 records, but I'm specifying the size and square footage and the price of the home. After that, what I want to do is be able to train the data, or train the model rather, on the data that I'm providing. So again, I'm going to load from enumerable, which is this house data. And then if you recall through that cyclical diagram we discussed earlier, we're building a pipeline and preparing it for the training. So we're going to do that by going into the ML context transforms, and we're going to specify what our feature is, which is our size, and then what our final output is going to be, which is the price. And we want to run through it 100 times to train it. We're going to train the model in step 3 using the fit method and using the training data that we specified in step 1b here. After we're done training it, now we want to test it, and we're going to make a prediction. So we're going to pass in a value that's not listed up here in the data that we're giving it. So this is for 2,500 square feet. We have 1,100, 1,900, and 2,800. And we want to see what value it's going to give us back for the 2,500 square foot. Once it returns that, then we're going to display it to the user. And we're going to wait until the user presses enter. So with that, let's, whoops. Go ahead and click start. And it's spinning up a console window. So I have it set at a breakpoint where it's going to stop at the instantiating of the ML context. We're going to assign the data and then load that data into the ML context. Next, we're going to specify that we need to concatenate the column for size as features, and then the price column is going to be the label column, the output that we want. Then what we want to do in step 3, like I said, train the model, and then make the prediction where we're going to pass it in 2,500 square feet, and it's going to display that predicted price for us. And so it predicted the price for a 2,500 square foot home would be $275,000. And so if we look at the prices that we gave it, 1,100 is 120,000, 1,900 is 230,000, and 2,800 is 300,000. So when we look at a price of a home that's 2,500 square feet, 275 seems to be right in alignment with the linear regression that we provided for it. Now, obviously, with the price of a home, there's a lot of other factors that are involved, and we'll talk about that in just a little bit. But so this is the second way of creating the machine learning model within the .NET application. And we've done it here completely programmatically, provided the data, trained it, and after we're done, we use the prediction method to be able to call the model and predict the value. And then after we're done, if we want to be able to save that model, if we trained it and we're satisfied with the results, we can save that model using the .save method, and then it will save it as a .zip file, where we can then take it and then pass it on to other developers, incorporate it in other solutions, or maybe even give it to our end customers. Let me pause here and see if there's any questions. And I don't see any questions yet. Alec, do you?
Nope.
All right. So moving right along. All right, so with the time to train, typically, if you have your data set that's 0 to 10 megabytes, typically it would take about 10 seconds. And obviously, this is going to vary. This is a general rule of thumb as far as the size of the data that you have. 10 to 100 megabytes is going to be 10 minutes, so on and so forth. In some cases, as you see here, if it's 1 gigabyte or more, it's recommended to invest at least 3 hours in training it. This is where the use of Azure comes in handy, because now I am not tying up my local machine. Not to mention, Azure is going to be much more powerful than my local machine. If I want to improve performance, more data, and not just more data, but it needs to be clean, meaningful data. So if you recall with the house example, we were just looking at square footage alone. In reality, what is the housing price dependent on? Location, the number of amenities I have, whether it's a swimming pool or a large backyard or a fenced-in backyard, et cetera, et cetera. A lot of other factors. Likewise, so with that, I have to provide the context that goes along with the data. Um, in addition to all the other features, if a house, for example, suffered fire damage or mold, I need to specify those things as well that could impact the price. So I need to put things in the right context as far as providing all the data that's needed and all the features and be able to build off of that. In addition, another option for improving performance is cross-validation. And what this is, it's a technique that splits the data into several partitions and trains multiple algorithms on these partitions. And so this allows me to be able to check which algorithm is more effective and produces better results. And obviously, using different algorithms, and as we had seen earlier, the longer I let it run, the more algorithms it goes through and trains the model. So where can this be applied? Obviously, there's a lot of real-world scenarios that utilize machine learning. So I can use this in my classification categorization, as I had seen with the customer feedback. I can use it for regression, like we did with the home pricing demo. I can also use it for anomaly detection to detect fraudulent transactions. If a user, for example, spends an average of $2,000 a month, and then all of a sudden, on one day, he has a charge of $3,000, obviously there's an anomaly that's happening there. And so we'll pick up on that. There's a far outlier that will need to be picked up on. I can use it for making recommendations as far as prices, where I should price my products. Instead of just assuming that every year I'm going to be increasing the price of my products by 3%, I want to look at and see what my other competitors are pricing at, what are the features that they're providing that could be increasing the price, and how my products compare to theirs dependent on those features. So I could use the machine learning model to be able to build on that. And all I have to do is just simply provide the data, and it will take care of all the computations. There's also a time series or sequential data where it's forecasting the sales and specific spikes. So for example, let's take FTD Floral, for example. They're obviously selling flowers 24/7 all year round, right? But what are the two peak times? Valentine's Day and Mother's Day. And those are pretty obvious for you and I. But for other things, for example, that are not so obvious, I can use this to identify peak times, whether it's high peak or low peak. And then last but not least is the image classification that allows me to be able to categorize images into certain things and be able to identify objects within those images. So a couple gotchas you should know about. 32-bit is supported on Windows, except for TensorFlow, LightGBM, which is an algorithm that's used for the prediction, and ONNX-related functionality. You may get the error that Microsoft.ml currently supports x64 and x86 processor architectures. Please ensure your application is targeting that. And to resolve that, basically just go into your project settings, build, and then set the platform target to 64-bit. Another thing you might run into is that the new project created by the UI may have a different version of .NET. And again, basically that's resolved by just simply adding the ML project and set it to .NET 5. And it may give you that message, but just simply add it in and you should be good to go. And so with that, typically for in-person presentations, I always ask what we learned today. And just as a recap, we talked about adding the machine learning model into our current .NET application. We can do this in one of three ways, either through the UI, we can do it through programmatically, or we can do it through the command line interface. If we do it programmatically, obviously we have to add in the Microsoft.ml NuGet package, and then we run through the entire cycle of setting the data, training it, using the fit method, and then evaluating it and making predictions after that. And then if we're happy with it, then we use the save method to save that off as a .zip. As far as references, if you check out the docs ML.NET guide on Microsoft, it's a great write-up on machine learning with a lot of great tutorials. There's also the ML glossary for terms, and you can find that over on deepai.org. And then a big topic is improving machine learning performance. And you can, again, the docs Microsoft did a great write-up on that. If you're interested in having this as a course, NIS Technologies offers courses in AI, and I myself and one of the instructors, I'd be happy to help you with that. And if you have any additional questions, just because the presentation is coming to an end, doesn't mean the conversation stops here. So you can find all my my contact information over on Linktree/Sam Nasr, but more specifically, my email, snasr@nistechnologies.com. You can also find me on Twitter @SamNasr, and my blog where I post blog posts on AI and machine learning as well as technical events, and that's samnasr.blogspot.com. And lastly, if we're not connected on LinkedIn, I invite you to do so. And so with that, if there's no questions or comments, I thank you all for attending, and I thank you all for having me.
Thank you, Sam. I'm gonna go ahead and stop the recording.